welcome back to my channel.
We had a weird delay on our screen. It counts down for us and it was at 1 for like 10 minutes. So, welcome back. Today we are doing word problems for exponential growth and decay. So maybe at the top of this, we should write that this is, oh, no, it's not always exponential. Just kidding, don't write that. I forgot, we're doing a mix of exponential growth and decay and regular growth and decay. So you can see down here we have 3 different formulas that we got to keep track of today. And that's probably going to be the hardest part about this lesson. So we're coming from reviewing what it looks like to have exponential growth or decay. And last time we talked about how we are going to focus a lot on natural growth and natural decay, meaning it's something that we see in the real world. The key to these exponential models is that they either grow very quickly or they decay very quickly. So we want to keep that in mind as we move through these word problems. It's either going to grow very quickly or decay very quickly. So let's talk about our different kind of problems we're going to have. So the first formula that we may need to use is this big old ginormous monster. Look how horrible he looks. That thing's horrible. This is the growth of things. This is the growth of things. So it gives you an example. Cars, money, houses, etc. You want to use this formula. The other ones are much more manageable. The other two give you an example of continuous growth and decay. And the key here is the word continuous. So the first formula is for things. The second formula is for continuous growth or decay. These formulas are essentially the same. So one of them is called the PERT formula because it literally looks like the word PERT, P-E to the R-T. This is the one that you use for science. So PERT is the one that you use for money. This other guy is the one that you use for science problems. But really, these two formulas are basically the same. The P and the A sub 0 represent the same thing. They both have an E, and then they both have something multiplied by T. So the letters just represent something different. Okay, so let's look at the really horrible one first. A sub t represents the present value after time. And some of this stuff is going to make more sense once we do a problem. P is your initial amount or your starting amount. R is your rate. And it's often given to you as a percent. So if it's given to you as a percent, you need to divide it by 100 to get the decimal. So R is the rate at which it grows or decays. T is time, how much time has passed. And N is this thing called period. N tells you how many times in a year it gets bigger or smaller. So if it says your interest is compounded quarterly, that means your balance gets bigger 4 times a year. So quarterly is 4. If it says monthly, that means your balance gets bigger each month. So that would be 12 times a year. Semi-annually is twice a year. Weekly, your balance gets bigger each week. That would be 52. And then if it says yearly or annually, that means that your period is 1. Your balance only gets bigger once per year. So this first problem is an example of the big ugly formula. Suppose you deposit $2,500 in a savings account that pays 6% compounded monthly. How much money will you have after 3 3/4 years? So your capital P, your starting amount, is $2,500. Your rate, they give it to you as 6%. So you need to type in 6 divided by 100 to whatever calculator you use. 6 divided by 100. I'm getting 0.06. You have to use a decimal there. I'm going to underline that because it's important. This has to be a decimal. So we deposit $2,500. It's going to grow at a rate of 6%. Our period, our N, is compounded monthly. So N is 12. My balance is going to get bigger 12 times a year. And then they want to know what happens after 3.75 years. So time is 3.75 years. So now we take all of those numbers. We say capital A of T, which is just fancy for the amount you have after 3.75 years. And we're going to plug all of this in to this formula right here. So the first thing that we're supposed to write down is capital P. That's 2500. The second thing is a parenthesis with a 1 plus R. R is 0.06. Over N, which we have as 12. We end that parenthesis and raise it to the N, which is 12, times T, which is 3.75. Holy shamoly. So let me zoom way in now. So I'm going to use Desmos because I know all the buttons. You can use your Canvas calculator if you want. Doesn't matter what you use. But I would strongly advise you to really do this and not just let me do it for you. So I'm going to go to Math Tools and I'm going to click on the Scientific Calculator. So it's the second option. And then it's going to give you a bunch of buttons that you can use. So we're typing in 2500 parenthesis 1 plus. Now hit your backslash to get a fraction. 0.06, arrow down, 12. Arrow out, end parenthesis. Now you do shift 6 to get up into that exponent. And let me see if it'll let you type in 12 times. Do you see how it kicks me out of the exponent?
Yes.
So to get around that, you have to use another parenthesis. So I'm going to put that on my notes. To get around that in Desmos, you have to put on another set of parentheses. So now it should let us type in 12 times 3.75. And it gives you your answer. You don't even have to press enter to get your answer. I'll press enter just so I can keep a running track. So our answer after 3.75 years, what we have in our account is $3,129. Let's just round to the nearest whole. Let's make our lives easy and just round to the nearest whole. So 3129. You're hanging in? So that's the big old ugly yucky pants formula. So using the same formula, and this is a little bit easier now if you keep your notebook open with both pages, since you need the info on page 78. You're doing something similar. So you are going to identify your capital P, your R, your N, and your T. So you don't have to plug anything in yet. I just want to see if you can identify what these values are. So I'm going to read it, and then I'm going to walk through once to verify that you guys wrote something down, and then we'll check in. A house purchased for $226,000 has lost 4.35% of its value each year for the past 5 years. What is it worth now? So this one's slightly different. Fill in the letters that you know. About 30 seconds. About 10. Okay, there's a couple things in here that are different. The first thing is that you lost money. So this isn't growth, this is decay. The second thing is the period they sneak in there. They're not very clear about the period. They say it loses value each year. So your principal amount or your starting amount is 226,000, 226,000. Your rate is 4.35%, but it is negative because you have lost this money. So we divide, so this should have given you negative 0.0435. That one's a long one. Your N is 1 because it said each year. Your period is 1. It loses value once a year. And then lastly, your time that has passed is 5. Your time that has passed is 5. 5 years. So now we can say the amount we have after 5 years, so that's A sub T, and now we fill all this stuff in. Capital P, parenthesis, 1 plus R is negative 0.0435. Make sure you get that negative on there. Over 1. And we're going to raise that all to N1 times T5. So you guys plug that in. You guys plug that one in. So I'm getting that our house is worth $24,454. Is that what you guys are getting? No, I typed in 50. I was thinking that was too low. No! That would have been a disaster. I would not want to type that all in again. Okay, this time I got 180,000. Does that sound better? Okay, so our house is now worth 180,939 because we're rounding to the nearest whole. You're okay? Okay, let's go to the next page. You guys try 5A without me, and your formula is right here. It's right above the problem. So do part A only. You invest 5,000 compounded semi-annually. You want to know the balance after 2 years. So you're trying the whole thing without me. Roughly 30. A. About 10. 5. Okay, so I have a balance of $5,519. How'd you guys do? Okay, the next problem says option 2. So they set up this problem with you invest $5,000 in an account to save for college. Option 1 is that you can have your interest compounded twice a year. Option 2 is that you can have your interest compounded continuously. And this is that other formula on the previous page, the PERT formula, and this uses the natural base E. So we're going to flip back, and we're just going to briefly talk about what all of these things represent. Now, personally, I think that this formula is way easier. P, capital P, is your principal amount. That's just the same as your starting amount. So technically, it's your principal amount, but what that means is starting amount. R, so here, I'm giving you the space to change this to a decimal. So R is your rate or your percent. And then this is just a reminder that if you have 5.3%, you got to divide that by 100. And that'll give you 0.053%. So that's just reminding you, you have to change it to a decimal. And then the only other thing that you need to know is T, or time. So this one, all you need is your rate, your amount, and the time. So we will flip back. And we'll see what happens if our interest is compounded continuously. So option 2 pays 4.5%. We're still at 2 years. So P is that same 5,000. R is now 4.5 divided by 100. So that's going to give you 0.045. And T is 2 years. So we're using this formula, and you don't have to write it down. I'll just write it down so it's right there. Principal amount is 5,000. E, natural base, to the 0.045 times 2. So now I'm going to come back here, and all I have to type in this time is 5,000, and then just type the letter E. Shift 6, 0.045 times 2. And this time we have $5,471. Is that what you guys are getting? Okay, so at this point, having it compounded twice a year is better. Just a teeny tiny amount better. Would you agree? Now they want to know what happens after 10 years. So if I'm using Desmos, I'm going to come back and I'm going to copy this last one that I plugged in. So I'm going to hit Control C, and then I'm going to Control V into the bar where you enter in your stuff. And we're going to change 2 to what? 10. So after 10 years, continuously gives you 7,842. And how I changed that was I copied this formula and plugged a 10 in instead. So now you can do the same for the big ugly formula. For me, I did that in my calculator. So I'm going to have to copy it from my calculator. And the only thing that you change is 2 times 10 in the exponent. Everything else stays the same. You just change that very last number in the exponent to a 10. So I'm getting 8,193. So over time, is the semi-annually still better? Yes. I think part of the reason why is because your interest rate on option 1 is a little bit higher. On option 1, it's 5%, and on option 2, it's how much? 4.5. Okay, so you guys try D. They want to know what happens if you start with 50,000. So do the same thing. Just copy. It's still 10 years. So you keep the 10, copy your work and fill in an extra 0 on P. You guys ready to check in?
Yeah.
For semi-annually, they're very similar. Instead of 8,000, I have 80,000, and instead of 77,000, about 800, I have 78,000. So all the way around, semi-annual was better, but I think that's because the interest rate was better. Are you guys feeling kind of okay at this point? Yeah. Okay. Let's flip back to this page. Let's do, so this Spider-Man problem, let's do a decay problem. So a car depreciates. A car depreciates. Do you guys know what that means? Loses value. A car depreciates continuously at a rate of 10% for 3 years. Your purchase price is $30,000. Just kidding, $35,000. So we want to figure out how much it's worth after 3 years. So all you need to identify is P, R, and T. So take a minute, see if you can identify your starting amount, the rate that you lose value, and the time for which you're losing that value. I added this one in because it's similar to one of your quiz questions. Let's go about 45 more. $30. 20. 10. 'P' is 35,000. R is negative 0.10 and T is 3. So if we plug that into our formula, we would get 35,000 e to the negative 0.10 times 3. So that's what we would plug into Desmos. What do you guys get as your answer? So 25,929. So in 3 years, your car lost $10,000 worth of value. This is why financial advisors say that you should never buy a brand new car. Because once you buy it, like the minute you drive it off the dealership's lot, it depreciates by like $5,000. Because it goes from being a new car to a used car, even though it's not really that used. I think that's very interesting. Okay, so we have one more kind of problem, and that's for science problems. But remember, these formulas are the same. The only thing that's different is the letters. So instead of having P for your starting amount, A sub 0 is now your starting amount. All that means is the amount at time 0. The A stands for amount and the 0 stands for time 0. K is your rate. K is your rate. So instead of using R, they use K. Here, this would be an example of decay. And this is just a reminder to take negative 2.7 and divide it by 100. So this would really be a value of negative 0.027. And then T, luckily, is time. In all of these, T is just time. So one thing to rely on, even though it seems like we have a bajillion different formulas, these two are really the same. So this is going to be related to science. That's our last page in our notes. A colony of bacteria is modeled by the function, and then it gives it to you. So this is modeling A sub 0 e to the kt. I'll zoom in. So the first thing they want to know is, what is our initial number of bacteria? 100. We started with 100. That's this first number here. Is this growth or decay? Growth. What is our rate? 0.045. We are growing at a rate of 4.5%. What about this tells us it's growth? It's positive. If that would have been negative, we know that it's decay. Then lastly, what is the population after 5 days? So all they want us to do is take 100 e to the 0.045 and multiply it by 5, which is your t. Your t is 5. Time is 5 days. So what is it after 5 days? That's a t of 5. So we can flip back over to Desmos. plug in 100 e to the 0.045 times 5, and our bacteria goes from 100 to 125 in 5 days. That doesn't seem to be growing very fast. You're hanging in? Okay. Number 7 is similar to a quiz question. In fact, they give you a graph and everything. So same setup, just different situation. Tritium and sodium-22 decay over time. In a sample of tritium, the amount Y in milligrams remaining after T years is given by, so this time they just give us the formula again. They're not even asking us to plug anything in. Okay, so these two are two different samples. There's one that matches this function, and there's one that matches this. So this is tritium, this is sodium. So this guy, tritium, this guy is sodium. Which sample started with the greater amount? Well, tritium started with how much? 10. Sodium started with 15. So sodium-22 started with the greater amount. Tritium started with 10, sodium started with 15. Which sample has a greater amount after 10 years? So for sodium, you just go to 10 years on your graph and you follow it over to the y-axis. So that's really low. That's like 1 or 2. For tritium, we actually have to plug 10 into the formula. So 10e to the negative 0.0562 times 10. You actually have to plug that in. So you guys plug it in because this mimics one of your practice problems. Holy moly. Sorry, distance learners. I was on the wrong screen for way too long. Teacher fell. I apologize. It's a bad day. About 20 seconds and we'll check answers. Yes. Thank you. About 10. Okay, I'm getting tritium. I got that tritium is 5.7. And I got sodium, oh yeah, so 6. I'm pretty sure I made everything on your quiz round to the nearest whole. Okay, so Do you want to do another example or do you want to try your quiz now? And then you guys will let me know if this wasn't enough for the quiz so that I can adjust. Yeah? Okay. Sorry, distance learners, that I was on the wrong screen for so long.